Okay, so I'm excited about this because this is now, the lecture today is going to allow us to branch out into word problems. Word problems are probably what most people are most scared of when they think about math.
I like word
Because word problems, you read something and you just like, huh? Where's the math? You know, it's like you just see all this gobbledygook. It's not set up into a nice, neat form, proper little equation that I can quickly solve. I have to figure out what that equation is from the word problem. In order to do that, though, the first step is learning how to translate words in English into mathematical expressions or equations, okay? And so that's what we're going to talk about. It's actually not that difficult, but until you start to see, until you see it and get used to it, it will feel a little complicated. But the truth is, all you have to do is exactly what it says. And if you read it exactly and do it exactly, you will see that it's the same thing. You'll see how to translate. Yes, Sal.
Isn't tonight's homework also like part of this?
Yes, this is actually tonight's homework, chapter 30, right? Chapter 30 is about this. And so, and it's relatively straightforward. Some of you may already know this, and that's fine. And that's awesome, actually. It's wonderful. But if for those of you don't, it's going to be very helpful. For those of you do, my guess is that there will be some things that will actually be a little bit new for you today, possibly. Yes, Micah.
Oh, never mind.
Never
I was
mind.
gonna say how today, like the 29th, we did it on the 29th, and then chapter.
Oh my gosh, that's so cool. Yesterday was the 29th and we had chapter 29. Am I amazing? Did I arrange this amazing? Like, today's the 30th, we're going to do chapter 30.
Tomorrow's the 31st.
Oh my gosh, that's amazing.
Gary, it's gonna be so
I didn't know
Gary's
that.
not gonna have to have homework. Oh yeah, Gary.
Oh. Well, we'll talk about that. Shh, guys, that's not for the video, right? We'll talk about that. All right, translating English into math expressions and equations. So, if you have something like this, the sum of a number and 10. So you read it from left to right. It says the sum of. What does sum mean again, Hunter?
The answer to an addition problem.
The answer to an addition problem. So we know we're going to be adding two numbers together, right? Right? The sum of, and then they give our two numbers. They say a number. Do I know what that number is?
X.
I don't. So it's going to be x, right? So that's going to be x. And it's the sum, so I got to add the sum of a number and 10. There we go. That's pretty easy, right? Pretty straightforward. The sum of a number and 10. The sum of a number and 10. That's what that is. All right. Let's try this one. The difference of a number and 4. I guess I should have moved over a little further. Well, I'll do it over here. So the difference, what does difference mean? Steph? Right. You're going to have two numbers and they're going to be subtracted from each other. Now the question is, which one do you subtract from which, right? Do you subtract 4 from the number or do you subtract the number from 4? Does anybody know? Liam.
I think it's 4 from the number.
Yeah, you actually write them in the order that you see in the sentence, right? And then you put the negative sign between the two numbers, right? So here we go. We've got the difference of a number, so I'm going to write the number, and, so that's my minus, right? 4. Look at that. So I put the number first and 4 second, right? Yes, Sal.
In Saxon, don't they use N instead of X?
Saxon often uses N.
That bugs me.
Makes no difference which you use.
I like
They do things.
thinking it makes it
N is just a variable. It's just a, I could use anything. I could use A, I could use B, I could use C,
I don't like
I could use
honestly,
D.
I was thinking
But there's a lot of numbers a lot of variables that look like numbers. S, really bad choice, right? 9S looks like 95. Always, whenever anybody writes it.
When you
Bad
have
choice.
a problem that is y or something, if you're accidentally in your math, change it to x. Like, so you see it and then you go x, and do the problem instead of y.
Right,
X.
like
Is
if
that
you,
okay?
if you, yeah, that's fine. Like if you're doing your homework and you're copying the problem down, which I hope everybody's doing that. That's what I want. I want you to take the problem and write it on your homework and then solve it. Don't just give me the answer, right? Right? So that's what I would like. And and what did you just say? Oh yeah. Sorry, I just got sidetracked. Sorry. But like, so you and it says 4s plus 3 equals 10, right? And you don't like s, that's fine. Make it 4x plus 3 equals 10, that's fine. Or 4a plus 3 equals 10, or 4n. They love capital N. I don't know why, to be honest with you, but
They
they
love
do.
K too.
They love K. Yeah. So that's fine, but they're just variables. That's all. They're just letters. All right, the difference of a number. How about the product? The product. So far these are really easy, right? They're going to get a little harder soon. So the product of a number and 28. That's fine. So if I was going to write that, I could write it in two ways. I could write it like this. Product means what again? Right? It's the result of a multiplication problem, right? So I could write it as a number times 28. But really in algebra, we don't do it that way. We don't usually put the number, the coefficient, in after the x. Remember? We put the coefficient before the x, right? So really, I would write it this way. I would write it 28x. Okay? So that's how I would do that. That's the proper algebraic way. Now what if I said this? The quotient. The quotient. Whoops. The quotient of a number and 25. What's quotient mean? Anybody know? Tess? Right. So it's the answer to a division problem, right? So I would say, and the thing is, well, now the question again is, which do I put on the top and which do I put on the bottom? I mean, I don't want to. Because x over 25 is different than 25 over x, right? 4 over 3 is different than 3 over 4. So I got to know which one I put on the top and which on the bottom. We always start at the top, right? Just like when you're writing on your homework and stuff and writing your notes, you start at the top of the page and you work your way down, right? So the first thing you come to goes on the top. The second thing you come to goes below that, right? So the quotient of a number and 25 is x over 25. Okay? I usually write them as fractions. I could write x divided by 25, but most of the time writing them as fractions is going to be easier for solving, right? All right, now we're going to get a little more complicated here. Let's say we have 4 more than. I'm going to underline more than. In fact, I'm going to circle it. In fact, I'm going to put little.
That's not a circle.
It exploded.
Well, it's a squiggly.
It's a squiggly,
Right.
squiggly red
Four.
block.
4 more than a number. I know what most people would do, and it would be okay in addition, but it would technically be wrong, right? 4 more than a number. What is the foundational thing in there? What's the base? The base is the number, right? You can't have, this is not, if I didn't have the word number there, I wouldn't have anything. 4 more than. More what? More than what? Right? I have 4 more than Satara does, right? I have 4 more what than Satara? I need to know what I have 4 more of, right? I need to know what Satara has so I know how many I have. I need to know my number first. so I put my number first. It's weird, but watch this. Whenever you see more than, less than, higher than, lower than, greater than, smaller than, faster than, slower than, you always put this number last. Okay? So think about it. It's going to be x plus, because more than, 4. Now, most of you will forget this. I'll just tell you, just from experience. Most of you will forget this. If you don't forget this, you will save yourself a lot of grief later when you're doing word problems. All right, so let's try another one. 6 less than. You got to look for that word then. Right? Right? Less than a number. What would it be? Yes, x minus 6, exactly, right? X minus 6. All right? That's really key. Most people, when they're not thinking, will do this. They'll do 6 minus x. You see why that would be a problem?
It's left or right.
X minus 6 and 6 minus x are not the same thing. You can always check by taking two numbers. Just two, 10 minus 6. Does that equal 6 minus 10? No, not at all. So you can always check by just substituting real numbers in there and see, wow, you got to get the right thing. It's 6 less than what? You got to have your number first, the x, and then you're going to take 6 away from it, right? Does that make sense? Okay, now it's going to get a little harder.
Yay.
All right, 5 times the sum of twice a number. Okay, can I erase this
Yeah.
so that I can keep working higher? Yes, for sure, everybody? How are we doing?
We've got
Getting
like
close.
1 minute.
We've got like 3 minutes.
I got 3 minutes. Okay, give me 3 minutes.
So
Okay.
no, it's 3 to 10 right now.
Okay.
Yeah. So that
It
is.
5 times the sum.
So we're
Twice the number.
He said it 2 to
that clock is
No, no, it's
5 times the sum
It should be a funny and
of twice a number and negative 5. 5 times the sum of twice a number and negative 5. That looks confusing.
Yes.
It's not as confusing as it looks. You do one thing at a time, 5 times. Now, I notice it says the sum, and I know the sum is going to be 2 numbers added together, right? So that's going to be, and I got to do 5 times all of that. So what would I do? How would I write a time sign on my code? Yes, so 5 times. Remember, parenthesis always means multiply. So 5 times, and now it just says the sum of, that means there's going to be 2 numbers here, so I'm going to have a plus sign in the middle. Twice a number, how would I write that? Twice? 2x, right? Yes, exactly. 2x and negative 5. Oh, so I could do, well, see, now I got parentheses here. Okay, I could do this, negative 5. Now the problem is you don't usually put plus and minus right next to each other. Which wins when you have plus and minus, Sal? The minus wins. So I'm going to just change it to 2x minus 5. So it's 5 times, okay, I got it. Thank you. 5 times parentheses 2x minus 5. That would be that one. I'm just going to do like 2 more of these and then we'll be done. 6 times the sum of twice the opposite of, okay, that's a good one. 6 times the sum of twice the opposite of a number and negative. Of twice the opposite, I forget how you spell opposite, 2 P's. Opposite, and I forgot what I was doing. The sum, what was I doing? 6 times. 6 times the sum of twice the opposite of a number and negative 8. Okay?
Thanks.
6 times, okay, so I just do that first. 6 times the sum of, I know I'm going to put a plus sign in the middle, the sum of twice the opposite of a number. Well, a number is x. What would be the opposite of a number? Negative x, right? So negative, it says twice the opposite. So negative 2x, right? Of a number, and negative 8. So I'm going to change that plus again to negative 8. And there we go. That make sense? All right, let me just see if there's any others that are the sum of negative 10 and 6. Okay, try one more. The sum of negative 10 and 6, negative 10 and 6, 6 times the opposite of a number. 6 times the opposite of a number. All right, so we got to think about this. The sum of, so we're going to know two things we're adding together. Negative 10, so negative 10 and, right, 6 times the opposite of a number.
6 parentheses.
So 6 times the opposite of a number. What's the opposite of a number?
Negative 6.
Negative.
Negative x, right? So I could do that. That's okay. Or I could rewrite it as negative 10 minus 6x to keep it simpler, right? Makes sense, right?
Yeah.
So that's probably enough for you to just, but you all can see I'm starting from the left and I'm moving myself to the right and I'm just doing everything it says, basically, right? You get used to it. It will really help because the word problems you're going to start doing soon, you will need to know that. Okay, I know I've got to get started. The other last thing I just want to mention is it also talks about decimal fractions in this particular chapter and decimal parts of a number. Like let me just one example.
Yeah, we're really running low on time.
It doesn't, so, well, I'm running low on time, so I'll just wait and I'll do that tomorrow. But I think you guys would get it. It's basically, if it says what is the decimal part of a number, right? That's just x. You don't know what it is, but once you solve for x, then you get a decimal as an answer, right? See what I mean? You don't have to put point x, 0.x, not like that. It's just x equals 0.3 times whatever, and then you find your answer. It's going to have a decimal answer. That x is equal to a decimal. So that's all. Okay, that's it for the lecture.